Hi, sir.
Hi, Amy, how are you doing?
I'm good. How are you?
Good.
Good, good.
Yeah. How was the test paper? Did you have a look at it?
Yeah, a little bit tricky.
Yeah, it
I
is.
did what I could.
That is right.
Yeah, it's
So
just graphing it. I find it really hard.
yeah, it is. The idea is that half of it kind of what you have done, and rest of half of it is what I want to teach you further. So that way
Okay.
the question paper has been made. So I hope with this we could finally close the unit on limits. That's the whole idea, right? So that's the purpose. And my test papers are normally open book test papers. You can always have them and spend your time in solving. But while you sit down and work on this test paper, I like you to allocate an hour and see how much you can do within an hour. That is kind of important, right? In today's talk, we'll actually discuss how to attempt a test paper and get the maximum marks which you can given a test paper. So this will be our sample test paper, and we'll try to see how do we maximize our learnings. Because I've seen many brilliant students failing to get very good marks. I mean, they know so well, and at the end of the test, the only remark they have is, "I could have done better." Now, no, that is the thing is over, right? So you could have done better has no meaning, right? We all
Yeah,
understand. We all understand it. We have to perform when we were supposed to perform, and that's what it is. So that is how I look at it, and keeping knowing fully well that we could have done better, right? But at least we should have touched that peak when it was required, and that is where I think, as a mentor and a guide, I have a role to play. So while going through the test paper today, we will see how to attempt this test paper so that we can maximize our position of getting marks. Because test paper is only testing you how much marks you can get. That's the whole idea, right? So we will begin by sharing this. But before that, I would like to have your own comments. How much, there were about, I think, 15 questions in this paper. How many could you understand? How many could you not understand? And how many were kind of you could do? If keeping that
right.
in mind, can you explain the paper itself?
Um, I couldn't do three.
Okay. Okay.
Um, like I officially couldn't even like do anything.
Mm.
Others that I could attempt, but like kind of got halfway. Um, about five or six.
Okay.
Yeah, and the
So
rest are okay.
that's okay. That's very good. That's actually not bad because if you're able to do 75% of this paper, I mean, you can grade yourself as the 90 percentile, right? Because the test papers are normally not just out of 100. We have to see how most of the students are going to perform on this. So if you get 75% on this, it is kind of 90 percentile, and that's not bad actually. So let me share with you the screen, and then we'll discuss the test paper. Okay, so I think you can see the screen now.
Yeah.
Okay, so here is limits lesson 3 exam review. The very first question which I have given here is limit x approaches infinitely large value of square root of 3x minus 1 divided by square root of 5x plus 1 plus cube root of 2x plus 1. That is extremely difficult question. Now, could you get this question, or do you understand how to answer this question?
I didn't get it initially, but then I watched one of your other videos, and then
Okay, that's a good
kind of
thing.
yeah, got through.
Perfect. And that is the whole idea. See, I have hundreds of videos. Now, when I am touching upon a particular topic, I will only be discussing few examples. So rest is there for you to explore. So you have to go through, many books, many reference materials, and sometimes you can always go through my list of videos and explore how to do such questions. Perfect. So that's a good thing which you did. Now, we'll move on from question to question, and I will actually suggest in this particular case, Amy, that whenever you get a test paper, it is a good idea to spend about first 5 minutes in going through all the questions. You understand? So
Um,
that you get an idea of what is there in the test for me to answer. Is it a very lengthy paper? Is it a very easy test paper? Is it a very difficult? It gives you a fairly good idea about what is it all, correct?
yeah,
And it also tells you, in a way, at what speed you should be answering. Because if you find that it is very lengthy and there are questions which will need more time than allocated, you will know exactly how to move around from one question to another, right?
yeah.
So instead of 5 minutes, today we are going to spend actually 20 minutes in understanding this test paper. How should it be answered, right? So be interactive with me. You need to read the question. I know when you want to scan the test paper, you could scan it in about 5 minutes. That's perfectly fine. But now we are going to analyze your scanning and develop a method of analyzing it so that when it comes in your actual exam in 5 minutes, you exactly know what to do, right? And in our next session, we will see how to solve this test paper. So in between, I'll give you time to sit and solve the test paper, and then we will discuss how to solve the test paper. So that is going to be our next meeting. So today's focus is to read the test paper, understand the questions, and then share with me what goes into your mind about answering this question and keep on moving from one question to the other. So here is the very first question for you, Emmy. I would like you to read the question and tell me about your own thinking. And as soon as you're done, I'll move on to the next question.
Okay. So evaluate limit of function f of x from graph. So, right, so the first question A says limit as x approaches -3 of f of x. So I would go to -3 from the left side.
So, so when you look at this question, you see a graph and you see that the limits are there and these limits are not very difficult and you can answer this, correct? This is what will come to your mind. Question number two is write domain and range. It gets into your mind, that is not difficult, I could do it, right?
Right.
Right. So we'll move on to the next question now. Have a look at this question.
So given f of x equals, so there's a few conditions,
Yes.
x plus 1 whole squared, where x is less than -1, x where x is between -1 and 1,
Yes.
where they're both included, and 2x minus x squared, where x is greater than 1.
Correct. And you
So,
need to find limits at different points. What
yeah.
goes into your mind? How should you be solving this particular question?
So I know that we obviously have to draw a graph.
Yes.
So that will make it easier. Then you just have to approach the different values that are given.
Perfect. And while you're drawing a graph, you should also calculate the values. Graph cannot be drawn without values. And the values are helping you to answer the questions. You're getting my point? Now,
Yeah.
here is a correction in this particular part B, where I wanted to write in part B as x approaches -1 from the left side. So this is minus on the top, right? So make a change in this. We'll write minus on the top from the left side, and C is approaching -1 from the right side, correct? So
Yeah.
now, what you are going to do here is that you will draw the x and y axis, and you know your critical points to work are -1 and +1. So you should draw a dotted line for -1 and +1, so you have a frame to work with. And for the very first question, you want to find the limit when x approaches 2. So you'll figure out where is 2 for you in your graph, and from the above, you know 2 should be 2x minus x squared. So that leg of the graph, which is x greater than 1. So substitute 2 here, you get a value, and you'll put this value on the graph itself, right?
All
So
right.
as you read and answer, you're developing your graph side by side. By the end of answering this question, your graph will be on the side and you can check all your answers. So that will ensure that you have perfectly answered this particular question, correct? Next question. Now, this particular question gives you basic questions on evaluating limits. Now, when you look at it, what goes into your mind?
So first I would substitute the value, which is the approached value, and see if I get an actual value. If I do, then move on. If I get an indeterminate form, which is 0/0, then I would have to use other strategies like rationalization, factoring, simplifying.
Correct. Now, Emmy, most of the time, the rule for solving a test paper is that you start with the first question and end at the last question. And that is what most students will do. So let us say that you began with the very first question and you were very encouraged. They were very easy questions to begin with. And you now end up in this particular set of questions to find the limits. The first two are very easy, definitely. Question number 6 could be a hurdle for you for some extent, since you're not very familiar with trigonometric expressions at the moment, right? Because we're not into really trigonometry. We have been talking more about polynomials and other functions, right? So that may be tricky for you. Then question number 7, kind of difficult. 8, maybe time consuming. 9, extremely difficult. Correct?
Mm-hmm.
Now, if you are moving through without going through the whole test paper, probably you will get stuck at question number 9 and spend so much of time here that your time for attempting the paper will be almost over. By the time you realize that very less time is left and there's halfway to go, it will be
Yeah.
too late. It will be too late. You get an idea? So normally in a test paper, there might be few hurdles in between. If you have a prior knowledge of what to, expect later on, then or you can make an attempt of skipping few questions in between. So at this stage, when you are there and when you're scanning your test paper, you should identify that there are a few questions here which I should definitely skip. Do you understand?
Yeah.
Another point which we are working on is that we are not always trying to get 100%. Our idea is to get 90-10. That means if I score more than 90%, it is perfectly fine for me. Perfect?
Mm-hmm.
So take a hit of 5% while moving along. Don't get stressed. So even if you get two questions in this set which you think are very difficult, in your mind you should say, well, it is just 5%, I can go with that hit of 5% and let me move around. I'll leave that, right? Still, you are 90 plus. You get the idea.
Yeah.
The strategy of 90 plus keeps you motivated and on focus to answer the test paper. And I think this is a very important strategy at this moment. Otherwise, if you get stuck here, you will not even reach 75%.
Yeah.
Now let's look into the next set of questions. How do you find these questions?
So, given that the limit f of x plus g of x exists, write functions f of x and g of x such that limit as x approaches 0, f of x, and limit as x approaches 0, g of x does not exist.
Yes. Can you answer this question for me?
No, this is the one I got stuck on. It was like, I don't even know where to start.
Perfect. Now let's try to understand the concepts of limits and answer this particular question. It is saying a very simple thing. Given that the limit of fx plus g of x, that means sum of two different functions, exists. So limit, when you add the two functions, exists. However, it says write function f of x and g of x such that the limit of f of x and the limit of g of x as x approaches 0 do not exist. So individually, the limit of these functions do not exist, but when you add them up, then it exists. Now can you answer the question?
So does that mean they would either be like poles or step functions? Or...
It could be 1 over x. So if I write 1 over x, then the limit does not exist when x approaches 0. Because we are specifying in this particular question that it does not exist at this particular point, which is x equals to 0. So focus on x equals to 0, go through the examples which you have already done, and reciprocal function 1 over x, the limit does not exist at x equals to 0. So that is a good example. But you have to give two examples. The other function could be minus 1 over x. You get the idea? So when you add them, it is 0. Now this limit of 0 will exist. 0 is a constant. And the limit of 0 at 0 will be 0. You understand?
Yeah.
That's the beauty of the question. It comes from, understanding of the whole concept. So if you know the concept, 1 second, even while reading, you will write down the answer and then move forward. Do you understand?
Oh,
So this is
right.
the stage where you kind of get a brilliant question and you have a brilliant answer. Don't miss the opportunity of nailing it right there and then move forward. Do you get the idea?
Yeah.
So this is the difficult section which I'm telling you how to do. So you have realized that we started with 1 over x as the only function where the limit does not exist at x equals to 0, right?
Hmm. Yeah.
And now we have a chance of making it into 2, means minus 1 over x. When you add them up, it becomes 0. And therefore, limit of 0 is 0. 0 is a constant, a number. Perfect. You get it?
Yeah.
Right, you get it. Very good. So that is one question which I wanted you to, kind of get it, because this is a very good question for any examination, right? And it comes, right? I've actually picked up all these questions from real test papers, Amy.
All
They are
right.
not fabricated. Now, you remember when we started our unit on functions, I asked you one question, and that was, give me an example of a function which is both odd and even. Can you tell me one function which is both odd and even now?
Would it be 0?
F of x equals
F
to
of
0,
x.
yes.
All right.
It is
Okay.
x-axis, and x-axis is symmetric to the origin and is also symmetric about the y-axis. Perfect.
Oh,
We are
yeah.
always working with this coordinate system. The most important system with which you are working at present is answer to many of your questions. Remember that, okay?
Okay.
Now, next question, question number 11. How are you going to do it?
So if limit as x approaches 3, f of x equals 2, find limit of x approaches 3 of f of x cubed minus x squared over f of x minus 5.
How will you do this question?
So what I did, so for each one, I made it as limit x minus 3, x
Yeah,
approaching 3.
perfect, good job.
And then I put it as f of x, and then I cube the whole thing, because we
Cube
know
of
what f
2,
of x.
right. So f of
Yeah,
x is 2, right? So you 2 cube is 8, and minus x squared, x is 3, right? So 3
right.
squared is 9, 8 minus 9 is minus 1. That is your numerator, correct?
Yeah.
Denominator 2 minus 5, which is minus 3. And you have your answer right there, minus 1 over minus 3, which is 1 over 3, and that's your answer. Perfect.
All right. Yeah.
You understand this concept? I wanted to teach you this concept. And that's
Yeah.
why I took these questions here. And these are very important questions. Question number 12.
Question 12. Okay. Sketch a graph of a function with the following properties.
Hmm.
Limit as x approaches minus 2 from the left side, f of x equals 3.
Mm-hmm.
And as limit as x approaches minus 2 from the right side, f of x equals 1.
Perfect.
And f of minus 2 is 2.
Yes. How will you sketch this graph?
Well, I just started by plotting the point minus 2, 2, and filled it in
Okay. So
as a
just
whole.
explain me. Your sketch will have what kind of a look? Graph.
I mean, that's all I got. I just plotted a point because it said f of minus 2 equals 2.
So you got 1 point, and that's a filled in circle.
Yeah.
Other two, limit approaches 3 when you're approaching minus 2 from the left side. It means what? How could you do it? At,
0.
at 3, you could make a hole and make a line on the left side of that 3, right?
Oh.
You could do y equals to 3, for example, which is coming from minus infinity till x equals to minus 2, and there is a hole at minus 2. It ends there. So from 3, make a hole, go left horizontally till infinity, make an arrow. So if you are approaching from the left side, as you approach minus 2 from the left side, you are approaching a value which is 3. You get the idea?
Wait, how do you know it's horizontal?
Horizontal line you can draw, correct? A
How do
convex
you
line.
know that?
Pardon?
How do you know it's horizontal line?
Or you can draw any line. It is up to you. You could draw a line which is increasing or decreasing also, but going
Oh,
towards the left side. Okay.
oh, okay.
So that's up to you. Horizontal is the easiest line. So similarly, from 1, you can make a hole and move a horizontal line towards the right. And at -2, you already placed a filled in circle. So you have your graph right there. You get the idea?
So it's like three, so it's a whole
Yeah.
dot hole, and then one's going right, one's going left.
Perfect, perfect. And
Oh,
the lines going right or left could be in any direction. You could make a parabola on either side, doesn't matter. Any curve, but continuous.
oh, didn't know
Any
that.
curve. So total freedom in this particular question. You understand now?
Yeah,
So these three were difficult questions, which we answered in few minutes. Do you see that? And
yeah.
that is what is going to happen. You are going, so imagine if you would have got stuck at question number 9, you would have never reached here. And you have already got 15, 20 marks while you're moving here, right?
That's true. Yeah.
So you have to skip and then get to the questions which you could do, right? Okay,
Mhm.
now we'll do the next set of 3 questions, which is the last set of questions. Explain me this. Question number 13. Read and explain.
If limit as x approaches 0, f of x over x equals 1, and g of 0 is not equal to 0, then evaluate each limit.
Correct.
So as limit x approaches 0, f of x.
Yes. So we are given the limit of the complete function f of x divided by x. And we know the limit exists and the limit is 1. However, we are interested in finding limit of f of x only. What should that be? Tell me.
Uh, you
When x
can't cross
approaches 0.
multiply, can you? No.
It is only possible if you get indeterminate form, 0 over 0.
Yeah.
Because the denominator is 0 for x equals as x approaches 0. That means the numerator has a 0 at x equals to 0. Correct? There
Yeah.
has to be a factor x there. So f of x is basically x times something else because there is a factor x which will cancel and
Yeah.
therefore you will have a limit of 1. Correct?
Yeah.
So you could say f of x is x times some other function, h of x. Right? When x and x cancel, then the limit of h of x is 1. You get the
Right.
idea?
Yeah.
But f of x has x in it. So individually, when we talk about this particular function, which is limit of f of x when x approaches 0, it has to be 0 because f of x is x times something, maybe 2. So 2x,
Oh, okay.
it is 0. Do you see that?
That was quite tricky. Yeah.
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 But it is concept. It's a communication thinking question in your test paper, right? So it has huge marks for your understanding of the topic, right?
Okay.
So I wanted to close this chapter with a clear concept and total understanding of the topic. And that is why I had kept them till the end. But I hope now you understand what we had been talking about and why limit was such an important concept. You get the idea?
Yeah.
Now the next question, answer the next part. We know that the limit of f of x is 0. We know that limit of f of x over x when x approaches 0 is 1. Now the question is, find the limit of f of x over g of x. Remember, g of 0 is not 0. So if I substitute 0 there in the denominator, you will not get 0 in the denominator, right? So what is the limit of this particular function?
Um, at 1.
0.
Oh,
Because
0.
f of x limit is 0 and g of x is not 0. Let it be some value 1 or 2 or 3. 0
Oh, but
divided by
0
3 is
divided
0. 0
by.
divided
Oh,
by 3 is 0. Got it, right? Tricky again. However, simple if you know the concepts. These are the time savers. You understand? The question paper was designed for about an hour to give you more time on questions like 4 to 9. But rest of the questions are easy to move forward, right? You should
I'm
identify
still
these questions.
I'm still a little confused about 13A. I don't
Okay.
really
Okay. So
explain it
13A,
again.
once again, limit of the function exists. And when you substitute 0 for x, you'll get 0 in the denominator. That
Yeah.
means limit should not exist. But it can exist if you get indeterminate form, which is 0 over 0.
Zero.
Correct?
Yeah.
So that means the numerator should be approaching 0 also. So
Oh,
the limit
oh,
of f
okay.
of x when x approaches 0 is 0. Is that clear now?
Oh, that makes sense. Yeah, yeah,
Do
yeah.
you get
Okay.
it? So
Yeah.
you can take it like this. I was giving you another explanation since there is another question in my mind, which could be there in your test paper, that f of x could be x times h of x. Do you understand?
Oh,
And we could
I
ask,
get it.
we could ask you, what is the limit of h of x?
Oh
The
my
limit
God.
of h of x is 1. Do you understand?
Yeah.
I could actually write f of x is x times h of x. And instead of g of x being introduced here, I will ask you, what is the limit of h of x? You will say that is 1. Because once
Oh,
we consider x and x, we are left with h of x. And the limit of h of x was 1. You get the
one.
idea?
Yeah.
But we took another question here, dividing by another function which is not 0 at 0, but the numerator is approaching 0. So the answer is 0. 0
Mm,
could be divided by any other number except 0. Perfect?
yeah.
Got it now?
Yeah, yeah. I
Good.
actually get it.
Clear.
Yeah.
Question number 14.
Oh yeah, this one I actually got. I was quite happy. Question 14. Show that the limit as x approaches 1, absolute function x minus 1, bracket x plus 2 over x minus 1, does not exist.
Yes.
So
How did you
what
do it?
I did was, so the piecewise function thing,
Perfect. One side limits piecewise function, they will not match, and you got it.
right?
When you do, yeah, it's a jump discontinuity. When you graph it, there's a different values, plus and minus something, and that is jump discontinuity at x equals to 1. Good job. Question number 15.
15. Right. Okay. So determine the values of a, b, and c for the function f of x equals ax squared plus bx plus c, where a is not equal to 0, that satisfies the conditions f of 0 equals 0, limit as x approaches minus 1, f of x equals 3, and limit as x approaches 2, f of x equals 6.
Yes. Could you do this question?
Yeah. So what I did was I initially, if it says it says f of 0 equals 0.
Yes.
So I just subbed in the 0 into the ax squared equation,
Perfect.
and I got c as 0.
Good. Correct.
Then so the main part of this question to unlock is that because we know that ax squared plus bx plus c is a continuous function.
Yes.
So therefore, limit x approaching minus 1 of f of x equals 3. We know f of minus 1 is 3. And we
Very
know
good. You actually
f
get a
of,
bonus point for giving this explanation in your test paper. So you
oh,
get an extra point for communication. This particular statement is such an important statement. And if you miss this, you would have lost 0.5 marks. Brilliant.
oh,
Yes. Next. So you have identified that there are 3 points, 0, 0, minus 1, 3, and 2, 6.
2, 6.
3 points
Yeah.
will give you 3 different equations. We need to find 3 unknowns, A, B, and C can be easily solved. Correct?
Yeah.
Perfect. That's not bad. I mean, you actually did perfectly fine on what all I actually taught you. You did all of them, right? So that's great. We'll actually look into the solution of these after you really attempt a paper, and then it'll be worthwhile for me to share with you the real answers, or how could you attempt. I mean, not the real answer, but how could you attempt. Now,
Yeah.
I'd like to have your views about what we did today. Was it helpful? Was it useful? Or it was just waste of 30 minutes?
No, it was definitely useful. Yeah, especially in exam conditions, like you said. I never used to do that, like just quickly run through all the questions and see. But now you said it, it's good to have an idea in your head, like which are the harder questions, which are the easy ones, which are the ones I can skip really quickly. And yeah, it's definitely good to look at questions and see what stuff I need to use, or you don't even need to solve it, you just need to know what strategies that need to be used.
Correct.
which is good.
And
Yes, it was so helpful.
yes, scan the test paper and plot your map of answering this examination. This is one of the most important thing for you. You have been working so hard for this particular exam. You can't let it go.
Yeah.
You have to nail it. And yes, you know that you may not be in a position to answer all the questions. That is expected, right? That is expected. So you should also know that you could skip some questions. The idea is to approach 100. The limit is 100. We have to
Mm.
approach this value of 100, right? Not necessarily being there.
Use the limits concept.
Just leave few and move on. And then once you save your time, let's say still have 15 minutes to go, then you get back to that question number 9 and say, now I should try it. And by that time, you've already gained so much of confidence. You're through the paper
Yeah.
and peace of mind, and you'll attempt it.
Yeah,
Even
that's
for
true.
attempting a question and getting a wrong answer, you might get 50% marks. And there you nail it. You are 97%. That's
Mm.
what we are looking for. You
It's
see that?
about going in with that mindset, that you're not going to get everything right and
Yes,
you're going to approach questions that are going to go wrong, but it's all
correct.
right. Yeah, and don't like stop at a question that you find hard because it's like a time waste, big time. Because there are so many questions like we just saw that I could actually do, but if I stuck on that question 9, I would never have got to them.
Yeah.
So
And remember, skipping is fun. Maths
yeah,
may not be that much of fun. Keep on skipping till you come to a comfortable zone, then
yeah,
do those questions and get back to the points where you skipped, right? So
right.
that could be an excellent strategy. Perfect. So I'd like you to now sit over your test paper, start all over
Okay.
again. Allocate now 45 minutes because you've already spent time on scanning and all those things, and see how you could do this test paper in 45 minutes. Take it like
Okay.
a real examination time, right? And we'll be back with you on actually uh, checking how you did and how we should be doing it. Perfect.
All right. Cool.
That's
Thank you
it.
so
And
much, sir.
that was right. Okay.
That was so helpful.
Just see you after you solve the test paper, right?
Yes, sir.
Okay then. Bye.
Bye, sir. Thanks.